The calculations for the acceleration of the vector table are pretty simple. The data we've already entered, your angle you've got from the setup video, and that goes here. The time you got from the execution video with visual physics, that goes here. The collection of data showed you how to find the distance in the x, the distance in the y, and the distance in the d. So really the only calculation we have to think about is how do I find these three accelerations? And we're just going to use this formula. X equals v naught t plus 1/2 a t squared, because we know our v naught is 0. So if I want to know my acceleration is going to come from this equation. So I multiply both sides by 2, and I have 2x equals a t squared, then I just divide by t squared. So I take twice my x. It doesn't matter if it's x in the x, x in the y, x in the d. I'll use the same formula every time, so I find my accelerations. Then after that, the formulas, they tell you what to find in here. I'm going to compare ax squared plus ay squared, compare that to ad squared. So I obviously have to calculate that and put in there, calculate that, put in there, and find the percentage difference. I have my angle, I have my acceleration, so I just calculate that. Make sure your calculator's in degrees, especially calculus people, because you tend to use radians. We will do everything in degrees. And then I'll find the percentage difference between this, the sine, and my ay, and your instructions will remind you of that. Then I find the ad cosine of theta. I find the percentage difference between this and my ax. And the last thing I do is the percentage difference between the tangent of the angle and ay divided by ax. And that's it. Good luck.